Okay, everybody, we're going to be working on problem number 13 from section 3.4. This problem asks us, or it says, suppose that the depth of the water at a popular surfing spot varies from 3 feet to 11 feet, depending on the time. Suppose that on Monday, high tide occurred at 6 a.m., and the next high tide occurred at 6:30 p.m. Draw a graph to model the depth of the water as a function of time t in hours since midnight on Monday morning. Then write an equation for the graph. So it wants us to draw a graph first to model this. So we're going to need to set up our axes. So we need to figure out what our domain and range is going to be. It gives us our range up here, so 3 to 11. That's going to be nice. We won't have any negative values, so it'll make that easier. And we're also going to start here at midnight on Monday morning. So we can start there and just move our time forward. So that makes it nice and convenient. So we'll go ahead and draw our axes. This is going to be our y dimension, which is going to be our height of the water. And then we can draw our x dimension, which is going to be our time. So for the height dimension here, we need to go at least up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we need to go at least up to 6:30 p.m. on this side. So we can do every 1 hour. I would suggest doing every 2 hours just to make it easier, I think, to find. There'd be too many tick marks. So we just need to make 12 of these. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? So that's going to take up our entire day. We just have to remember that we're going by 2 hours per tick mark on the bottom. So let's start plotting our points. So one of the points that we can point out here, it occurs at 6 a.m. Okay, so it's 6 a.m. and it says that it's a high tide. So that means that we are going to be going to the maximum amount of height of our water, which is, in this case, 11. So we need to go to plot our point at 6:11. So 6 will be 3 tick marks over on the right, and then all the way up to the top. There we go, 6:11. All right, so now we have that. It also tells us that our next high tide is going to occur at 6:30 p.m. So all we have to do is just move on down the line, plot another point down the line. So since we wrote our axes like this, we need to kind of convert this to military time. So just add 12 to the 6, okay? Add 12 to the 6, and you should get 18 hours, so it'll be 18 and a half here. So we'll find this point. We get 6, 8, 10, 12, 2, 4, 6. And we'll be right up here. Once again, this is a sketch, so you want to get as close as you can, but it's okay if you're a little bit off here. Okay, so now that we have those 2 points, we just need to find our minimum, okay, in order to sketch what we have here so far. So what we need is we need to know that a minimum is always going to occur halfway between 2 consecutive maximums. So if we take this distance here and go right down to the middle, we should have our minimum point, which should go down to about 3. Should be at 3. So we just need to do 18.5 minus 6 should give us at 12.5. So the distance between the two of them is 12.5. So we're going to divide that by 2 because we want to go halfway between them. So that should give us 6.25. So we need to move from this point 6.25 over in order to find our minimum. Okay, so we should plot our point at 12.25, which will be 1, 2, 3, 4, 5, 6, and a little bit over at 3. Excuse me, so this should be 12.25 and 3. Okay, so we've actually got our point set up now, so we can actually just go ahead and draw this line. Important thing to remember when drawing these lines is to go ahead and kind of curve them out a little bit. So it should look something like that for what we have. And this is, of course, going to go on for infinity, okay? It's going to go on forever in both directions. But this is the only points that we need to know right now. Okay, so we've actually got a little model of our depth here. We can trace this back as best as possible, and that should give us some good information here. So we should get something similar to this. Once again, it's not perfect. But so now we need to go back and we need to find all of our parameters so we can write our equation. Remember, our equation should look something like this. Y equals A times the sine of B x minus C plus D. Okay, so we're looking for A, B, C, and D in this case. So A is going to be the max minus the minimum divided by 2. So we should get the maximum occurs at 11, the minimum occurs at 3, and we'll divide that by 2. We should get 4. Okay, so this is always the case for A, because that's going to be the max minus the min over 2. So we'll get 4 here. We want to find our B value. So our B value is going to be it's going to be 2 pi over the period of our graph. So 2 pi is always there. And then our period is going to be the distance between consecutive maximums, which, since it's in time, makes it kind of easy. It's just going to be 12 and a half. Okay, it's just going to be 12 and a half here. So 12.5 hours. Okay, so we're done here. You could list this. You could rewrite this as 4 pi over 25 if you want to get rid of the decimal, but I'm okay with the decimal in this case. Next thing we need to do is we need to go and find our D value. Remember, we want to find D first because our C value will depend on it. So D, all we do is the max plus the min divided by 2, which should get us, if we go back up to A, we just add a plus sign in there, so we should get 14 over 2, which gives us 7. Okay? So positive 7 for D. So now we just need to go and we need to draw our line going up to 7. 1, 2, 3, 4, 5, 6, 7. That's a little sloppy, sorry, but we just need to find where our graph intersects here. So looks like right here is going to be our C value. Based on how you sketched it, it could be a little different for you than it is for me. I'm going to take a guess and say that we're intersecting right there at about 3. So I'm going to get C equals 3. Okay, so since we're sketching this, it becomes a little difficult, but I'm just going to go ahead and guess there. So what we have now is our A, B, C, and D. So all we have to do is now write our equation, okay? So, and once again, yeah, also the slope is positive here, so we're going to have a positive sine graph. So we're going to go over to the next slide, and we should get y equals, if we go back, A is going to be 4, so we get 4 sine. Our B is 2 pi over 12.5. And that looks weird, but you know, sometimes you're going to get some weird numbers here. And that's going to be x minus our C value, which is 3, and then finally plus 7. So not only have we gone through and sketched this graph, but we've also used the information from that graph to determine our equation. Okay, so the only one that was kind of a little bit up in the air was our C value. With a more accurate graph, we could determine that. But for our sketch, looks good. All their data is correct, and we're left with this equation here. Okay, so study up on this because this is a good test question. Um, and there's also a practice problem in the extra practice at the end of this chapter with a question just like this. It should be number 16.